So now in this video we're going to add some more of these 18650 batteries. I buy them from EBL. They seem to be the lowest price for the amount of energy they store from what I found. So they are not intended for outputting high amounts of current though, but they claim a 3000 milliamp hour rating. From my earlier testing, I'm pretty sure it's actually 2000 milliamp hours per battery. So what that means is this battery, if it could actually provide 3000 milliamp hours, to make the math easy, that would be 3 amps for 1 hour. So 3 amps is a whole lot of current though for a battery. So that's about how long it would probably take to go from 4.2 volts to 2.5 volts. And you don't want to exceed those limits, so you should probably keep it to 3 volts or above during discharge and not charge it above 4.2 volts. You could even charge them to 4.1 volts and be a little safer, but many chargers don't make it easy to do that. So in any case, that's each battery. So here you can see we have them in series. So these two batteries are connected up there, but down here their positive side is connected to the negative side of those two batteries, and then so on. The positive side up there to negative, positive to negative, and then we have the positive there, right there. So they're in series. So when they're fully charged, they'll be about 4.2 volts each, and so if you have that much voltage, that will be 16.8 volts across all of them between these 2 points. That's why you put them in series, so that you can get more voltage. The current travels through the battery pack and then through the load and back again, and so their voltages add up. Each one of them keeps pushing. So I say each one, but actually they are in parallel, so we have one next to each other. So as long as they can provide the same amount of power equally, these two, then when you have a load, they will be pushing the same amount of current. And it's very dangerous. I can do that with my fingers. I have a lot of resistance, but you don't want low resistance short-circuiting any of these points, because then the batteries will be powering each other and very, very high amounts of current will go, and probably one of them will be hopefully just damaged where you can't use it anymore, but it might catch fire and whatnot. So don't put this on a conductive surface, and don't let any wire or anything drop across there. And so we put them in parallel because, as I just said, each one of these will handle half of the current, and they're, as long as they're equal in all aspects, they should drain equally. The one that is stronger will provide more current and whatnot. So there may be imbalances, but that's why you want to use the exact same batteries if possible, the exact same capabilities. And so you put them in parallel to split up how much current each one is providing, both to extend the life twice as long per charge, because you have 2 of them providing current instead of 1. So they'll be able to do that for twice as long. And also so they don't get too warm. So if you have a lot of power needs and the battery will get too hot, you can just add 1 or more in parallel. But you also need to add 1 in parallel for each series here. So we're going to add parallel here. We're going to have to add 4 of them. Also, I have this pouch here. In case something goes wrong, they'll start venting explosive gas. And so pouches similar to these, I actually put it in one that you zip up and stuff, but usually they're not airtight, but they don't let a lot of air out. So there's a lot of videos out there of these pouches kind of like these being tested, and the 18650 batteries aren't as big of a danger. It's more the big flat ones. So one single battery, and it'll be storing a whole lot more energy than an individual one of these. So one of these might catch fire, that might catch the other one that's on fire or whatnot. So pouches like this, they let the gas vent and try to keep the flame there may be a little flame that comes out, but hopefully there's not even any flame. The gas just vents. And I've seen other ones where the batteries catch fire or something. You just see the bags just really puff up and some smoke comes out of them and stuff, but finally they put it out. Whereas if you have oxygen near there, the flames consume the batteries. And so that's videos for other topics. So this isn't something to play around with. So in any case, what we're going to do is to add these in parallel to begin with. We are going to take the same colors and we're going to plug them in as we see here. So you see the I think that would be a ridge or whatever there and there. So we want to do the same thing. Ridge there and there, and that is going down the line. So once we got one, the direction of one, actually it's upside down, there you go. So once we got the direction of one of them, and you notice we have a groove there and a groove there, we can just keep going down the line. And one thing I did was I kind of pushed these together and I took them apart, and I find after you do that once or twice it gets a whole lot easier. So I did that with all of the slots there. So we have a blue one, red one needs to go in the same direction, and we just continue the process like that, and it's pretty straightforward. So I'll get that one in, and then we'll just jump ahead for the rest of them. So now we're going to add the next battery, and you notice since we're going to add them in parallel, the color has to line up with the other ones going across there, and then we will add bus bars across there and then bus bars across there, but not across there. That will short circuit it. That will provide a path, continuous path there. So in case we have those there, and what we can do now is put a battery partway in. Don't have to go all the way in, and but a snug fit is a good idea. And again, so the ridges here, I'm just going to call them that, and then the grooves there, they're the opposite of what is down here. So you can see that now it's this side that has these two ridges or whatever you call them over there, and so that's for all of them. So we come here and you can see we have actually I had it sideways. There you go, we have it like that. So yeah, it's, you got to be very careful, especially with the first one, because the next one won't fit if the first one's not put in properly. So there we go, and we got to get it into the battery. That's why it's kind of nice to leave the battery up a little bit. Make sure you're getting the battery, and then start sliding it down. And there we go. So far we could kind of leave it like that. I bought this clamp here. So now this clamp is plastic, that's rubber, plastic. This is metal, this is metal. You don't want any metal near the metal on here, so be careful. And so what we're going to do is, there it is we're just going to clamp down. I'll try to keep it where you can see pretty good. And up here, it's a little narrower than back there. So we can put that to the battery. So now you press this lever, you slide it open. I'm not going to put hardly any pressure on it. My only goal, oops, I missed up here. I was looking into the camera. My only goal is to, since these are decently spaced, to squeeze it down until they touch each other. Right there. So that's pretty close. So we can improve it a little better if we need to. So I didn't squeeze it down. You can see we're still not quite perfect, but we have a good fit. We will touch this up a little bit later after we add more batteries. And all we'll squeeze it to is to level it off coming up. And now we will do another battery. And it would have been a good idea to check the voltage of these batteries first. I actually did. These are about 3.65 volts. These are new ones, and then the other ones are about 3.7 volts. So I think they are close enough in voltage where it's perfectly safe to wire them up already. But I'm going to show you a way to balance them. So now we have teeth there, we have no choice but to put a groove there, and that makes that pretty easy. So the first one is the one you can kind of mess up, and this one would not slide into place if the first one were not lined up properly. So let's set that, make sure that's lined up there, and that the battery is going in. And again, you don't want to use more force than you have to. I missed those teeth over there. There we go, much better. And then again, we would that went in pretty good. I'm not going to clamp it yet. We can clamp it when we're done. So I'm going to finish with those other two. Alright, so I finished making the connections, and then some of them are higher than others, so I clamped them. I made sure though that I stopped once the clamp touched the other side there. And then same with this side. I made sure it was going across there. So right now these batteries are not connected to anything. We'll double check blue, red, because we don't want to put one in backwards. And also we can look at the way the battery's going. You can see the stripes there on all those, and then we'd want to check the stripe is on the other side of all those, and then so the stripe there is on negative, stripe negative. So that would be a good thing also to check. And what we can do now is check with the multimeter of the voltages. And so you can plan ahead for this. Right now the batteries aren't attached to anything, but if I put the black probe down at the bottom here, you can see that we have 3.73 volts, and we can do that with all of them. If we accidentally put one probe backwards, or the probes backwards, we'll just get a negative voltage. But there you can see 3.7. If we measure it this way, it's negative 3.7. So it just lets you know you got the probes backward. Doesn't damage anything. And this one, so when they're in series, they will not be all equal value. You want to try to keep them to the equal voltage, but some of them are just going to kind of drop in voltage faster than others. That's why balancing is important. And so now we saw voltages of those. So this one, and these are all, I just took them out of these boxes. They had a little sticker there, a little seal, which when you peel it off you can see void on there. And so all of these are probably about spot on the same voltage, 3.64, and this one will be a negative, but 3.64, and just a speck higher, not a big deal, and negative 3.6. So I'm going to show you a way to easily balance this using just a resistor. And so to balance this with the resistor, we need to connect one side, but only one side of the battery to the other one it's going to be parallel with. And so this side's a little easier to see. We will unscrew this, and the reason why we don't connect both sides is because, and there we go, luckily that was a short piece of metal, could be easy to short circuit. So as long as the clamp didn't put too much pressure on the line there, it should pop out pretty easy. So there we go. We will screw this down, and then also we will have to screw that side down. So I'll get a nut for that one, and this is a 5.5 millimeter. I think it's called a hex wrench, and so this is an unusual size. So I actually had a tool kit in my car that had an attachment that was the right size, but Vruzend, which is I think the only place that sells these Vruzend connectors, they also have the wrench that you can buy there, and I suggest buying that because it's an unusual size. And as you can see, it works pretty nice right there. I have that down tight, and then that side down tight. So now that we have them connected, we have the meter there set to measure voltage. They're only connected on one side though. That's the important thing if we are balancing it. So on this side they're all connected already. We're going to connect them on this side too, but not yet. First, let's take a look at what voltage difference we have. And actually, this is low enough where we don't have to worry. We can make a direct connection. This one is 3.673 volts. Those two to the right, and the one to the left there, which is not connected on the bottom yet, is just a tad bit lower, so not much. And so what we're going to do is, before we put a bus bar with no resistance across it, we're just going to bridge that gap with a resistor. So this is a high wattage resistor. We're actually not going to get much current. This is 10 watts. There's not much voltage difference, but the more voltage difference you have and the less resistance you have, the hotter it's going to get. But ultimately, the higher voltage ones are going to charge the lower voltage one. So now, let's do that for a little while. So it'd be better to screw it down or whatever, but as I said before, this is a higher value resistor for the low amount of current that we expect. And so we can just kind of temporarily touch them. It's not going to take too long, I don't think. So the ones with the higher voltage are feeding current into the one with the lower voltage until its voltage rises enough that they are equalized. So I'll just hold this here for a little while and we will take a voltage measurement. And instead of holding it, I have the alligator clip, and this hasn't been going on for a while. These store a lot of energy, so it's going to take a while, especially with this higher resistance of 10 ohms for the little voltage difference we have. But there you can see we got 3.645 on that side and 3.673 over there. We can check the voltage across the resistor, which will let us know how much current is going across there. So that's how low the voltage difference is, but there is a voltage difference, so a tiny bit of current is flowing. And if there's a bigger difference, there would be a bigger voltage across there, and more current would be flowing from these to the other. But ultimately, we're going to get a point in between the two differences, and since there's two on this side, it's going to be closer to the voltage on this side, that all three of them will ultimately they'll be equalized. So now, after it's equalized, as we saw, it was pretty much equalized to begin with. Then we can now connect it in parallel. So we got that side, and so we just have this side to attend to. Let's remove this nut there. There we go, it's off. It's down there, and just put a jumper across here. So you want to take your time. As I said, these are dangerous. So you can see they're all connected there, so we can connect all of these there. We may need to balance that, we may not. We actually don't have to balance it. But so we got this side, and so it's good to be careful and make sure. Last thing you want to do is short circuit something. So you never want to connect any conductive area here with this conductive area there, because they're already, I gotta hold the bus bar there, they're already connected on this side. So if you connect any of these to that one, it's going to short circuit, which is a bad thing. And then we can just take a couple nuts here and we can screw this one down, but we'll do the same balancing thing if we need to with the other batteries. You connect one side of them where they're going to connect, and then leave the other side unconnected, and you make the connections with a resistor to limit the current. But you got to be aware of the power rating of the resistor, how much current's going to flow, and it's best not to hold the resistor. They're going to get hot, but if the current's low enough, it's not going to get very hot. So that's really all there is to it, and it's pretty simple. So I'm going to end the video there. You just keep following that process to build up a battery pack, and I think this way, snapping them in one at a time and connecting them one at a time, checking them one at a time. You want to make sure the battery's good though before you put it in there. I actually had some that died, that they were in a charger that apparently was letting current go through after it was off, and so they were completely dead. I got rid of them. So it's good to check them beforehand. But the main takeaway is they should be balanced before you connect them, and electrically you can snap them in with this system, and if they're unbalanced, and use a resistor to level that off. And so that's the main takeaway. So hope that all made sense. Those are topics to investigate further if they are new to you. This is very dangerous, as I said before. So don't jump right into doing this. Take your time, learn what you're doing, and it's going to be a lot of fun building up energy storage system. So thanks for watching. I'll see you in the next one.